तो दोस्तों कैसे हो आप सब? Yes, hope all of you are doing well. So in our previous video we started with this topic, that is alkenes, where we have discussed some introductory part regarding alkenes, then followed by nomenclature, and then isomerism in alkenes. Yes. So in today's lecture we'll discuss methods of preparation of alkenes, right? Okay, so alkenes, they're mainly prepared by two reactions, of which the first one is known as elimination reaction. It's a elimination, and the second one is addition reaction. So by these two reactions, we can make alkenes. First one is elimination, and the second one is addition reaction. Okay, so let us start with the first method of preparation of alkene under this title, that is elimination reaction. So have you heard this term elimination? Yes, in number of TV shows or in number of competitions, you might have heard this word elimination. Eliminator round is there. Okay, like that. So elimination is nothing but what? It's a loss or removal of something. Okay. Now this elimination reaction is also known as, it is also called 1-2 elimination reaction. It's a 1-2 elimination reaction, or sometimes it is also called beta elimination reaction. 1-2 or beta elimination reaction. Okay. So by this elimination reaction, it is possible to prepare alkenes. So let us see first a reagent, we can say, a reactant, we can say, by which this particular reaction we can make alkenes. So the reaction is dehydration. It's a dehydration. Dehydration of alcohol. Dehydration of alcohol. So this leads to what? Yes, alkenes. This leads to alkenes. Okay, now dehydration. Here D stands for loss. D means loss or removal, we can say. Loss or removal. And hydra, it is related with what? Water. Okay. So loss of water, that is minus of what? H2. From what? Yes, alcohol. Is because it is known as what? Dehydration reaction. So your reactant is, it's a alcohol. Now dehydration of alcohol, it can be carried out by using number of dehydrating agents. Number of dehydrating agents are there, of which we'll discuss. Okay, let me first of all write here some examples of dehydrating agents. The first one which we use over here is the concentrated solution of sulfuric acid, concentrated H2SO4. Or you can also use Al2O3, called alumina. It is known as alumina. You are familiar with this alumina. Okay. Then instead of this, you can also use here KHSO4. It's a potassium bisulfate or potassium hydrogen sulfate, potassium bisulfate. Then P2O5 is also there. That is phosphorus pentoxide, diphosphorus pentoxide. Then concentrated HCl is also there. So number of dehydrating agents are there. Okay, of which we'll see dehydration by using these two, concentrated sulfuric acid and Al2O3. Actually, in our 11th standard textbook, chemistry textbook, only one dehydrating agent is given, that is dehydration of alcohol is carried out by using only this dehydrating agent, which is concentrated sulfuric acid. But remember, in next year, that is in 12th standard, this reaction is repeated in a lesson, that is alcohols, phenols and ethers. You will find this reaction as a chemical property, or under the title chemical property of what? Alcohol, that is dehydration of alcohol. And वहाँ पे ना दोनों रिएजेंट के साथ डिहाइड्रेशन रिएक्शन दिया है हमें. Okay, using both dehydrating agents. So let's see this dehydration of alcohol. Now dehydration, yes, what is dehydration or what can you say about this dehydration of alcohol? It's a reaction in which water molecule from alcohol gets lost. That becomes dehydration of alcohol. And very important or notable point is that whatever the dehydration occurs, that always occurs from adjacent carbon atom. Means H. Actually, water on dissociation gives us what? Two ions, that is H plus ions and OH minus ion. Okay, H plus and OH minus ions are the ions of what? Water. So this H gets lost from one carbon and OH gets lost from another carbon. Okay, so loss of water molecule, that is dehydration, it always takes place or it always occurs from adjacent carbon atoms. Okay, means OH resides on particular carbon atom. So with respect to that carbon atom, whatever the neighboring carbon is there. So from that carbon, hydrogen departs or hydrogen gets lost. So let's have an example. Suppose if I have this CH3, then CH2, and then OH. That's a well-known alcohol. It's a ethanol. That is ethyl alcohol. Okay, also called grain alcohol. It is also known as grain alcohol. Now OH is present on this particular carbon. So with respect to this carbon, it is the only neighboring carbon. It is the only neighboring carbon. So OH lost from this carbon and H gets lost from this carbon. So let me write this methyl group in a splitted manner like this. CH2 and H. That is what? CH3. CH3. And I'm putting this OH over here. OH. OH. So H and OH, they gets lost from adjacent carbon atom, creating double bond between two carbon atoms. Means H departs as H plus ion, meaning these two electrons, they get shifted in between these two carbon atoms, and OH gets lost by taking both the electrons. So it departs as OH minus. Okay, so this dehydration is carried out by using concentrated solution. Not only concentrated solution, we need a 95% concentrated solution of sulfuric acid, and reaction occurs at 443 Kelvin. Okay, where water molecule gets lost, giving this CH2 double bond CH2, and plus what? Elimination of water molecule H2. Okay, got it? How this dehydration occurs? Yes. CH3, then CH2, and then OH. Correct? Yes. Now, if I use here this alcohol, CH3, CH, then CH3, and OH. OH. Now, this alcohol is known as isopropyl alcohol. It is called isopropyl alcohol or isopropyl alcohol. That is propan-2-ol. It's a propan-2-ol. That is secondary propyl alcohol. Okay. And if you use here this alcohol, if you use here this secondary propyl alcohol, that is isopropyl alcohol, then condition becomes mild. We need here just 60% concentrated solution of sulfuric acid, 60% concentrated sulfuric acid, and reaction occurs at 373 Kelvin. Okay, so for this particular alcohol, condition becomes what? Mild. Temperature also reduces to 373 Kelvin from this 443 Kelvin, as well as concentration of sulfuric acid also decrease. Okay, again OH resides on this carbon, so with respect to this carbon, it is the carbon number 2 or adjacent carbon. Similarly, it is also adjacent carbon. Okay, so now two possibilities are here. Means H gets lost either from this carbon or from this carbon. But if you check the equivalency of these two carbon atoms, then these two carbon atoms are equivalent carbon atoms, because both these carbon atoms carry 3 hydrogen atoms. Okay, that's why they are equivalent carbon atoms. So you can remove H from any of this carbon, okay, resulting same alkene. So if I remove H from this carbon, so double bond gets formed between these two carbon, because OH and H, they get lost from adjacent carbon, creating unsaturation between the two neighboring carbon atoms. So H departs from this carbon and OH departs from this carbon, giving this alkene CH3, then CH double bond CH2 with elimination of water molecule H2. Got it? Yes? Okay. Now let us have this alcohol CH3, then C, then CH3, then CH3, and OH. Now this alcohol is known as, it is called T-butyl alcohol. It is called tertiary butyl alcohol, tertiary butyl or tertiary butyl alcohol. Okay. Now for this alcohol, condition becomes very mild. We need a just 20% concentrated solution of sulfuric acid H2SO4 and temperature is 363 Kelvin. That is 90 degree. Here it's a 100 degree. Now OH is present on this middle carbon atom. So with respect to this carbon, it is carbon number 1 means it is carbon number 2, carbon number 1 means carbon number 2, carbon number 1 means carbon number 2. So all these three carbon atoms are neighboring carbon atoms. Now check equivalence of these three carbon. Are they same or different? Are they equivalent? Yes, they are equivalent because the substituents of these three carbon atoms are same. Each carbon atom carry three hydrogen atoms. That's why per mole of H from any of these three carbon atoms gives us what? Same alkene. So what I'm doing? I'm taking hydrogen from this carbon atom. Okay, so double bond gets formed between these two, so that H and this OH they couples together giving water molecule. So you get this compound CH3, then C, then CH3, then double bond CH2 with elimination of molecule of water. Now this compound, yes, it is called, good, very good. It is called isobutylene. Isobutylene. That is 2-methyl propene. Okay, got it. So it's an means these are some examples of what dehydration reaction. Now why the conditions are different for different types of alcohol, for different alcohols? Yes, it depends on the nature of alcohol. Conditions for dehydration depends on nature of alcohol. Okay. So let's see that nature. Nature means alcohols are actually classified into three types. Okay. Which are called primary alcohol. Sorry, monoidic alcohols. Means the alcohols containing only one OH group, they are called monoidic alcohols, and they are classified into how many types? Three types. So first type is known as 1,0 alcohol, 1 degree. Okay. Second one is it's an example of 2,0 alcohol. It's a secondary alcohol. This one is a primary alcohol, and this one is an example of 3 degree alcohol. Okay. That is tertiary alcohol. So alcohols are classified into how many types? Three types: as a primary alcohol, as a secondary alcohol, and as a tertiary alcohol. Now, how to identify the type of alcohol? Yes. You must be in position to identify the nature of carbon carrying that OH. Okay, so your OH is present on this carbon, and this carbon is here as a CH2. CH2. You just remember that CH2 carbon is a primary carbon. क्या हमें याद रखना है? CH2 कार्बन ये प्राइमरी कार्बन है. यहाँ पे OH है मतलब अल्कोहल है. ओके, सो टाइप कौन सा हो गया अल्कोहल का? अल्कोहल का यस, प्राइमरी अल्कोहल हो गया. अगर यहाँ पे Cl है, Cl मानो Cl है, तो क्या होगा? यस, ये प्राइमरी अल्किल हलाइड हो गया. यहाँ पे NH2 है, NH2, सो क्या होगा? ये प्राइमरी अमाइन हो गया. ओके, एंड सो ऑन एंड सो ऑन. So here this CH2 carbon is a primary carbon. So fix करो ओके मध्ये. Then next here in second case, OH is attached to what? This carbon, and the nature of this carbon is a secondary carbon. So CH क्या याद रखना है हमें? CH कार्बन जहाँ पे दिखेगा उसका नेचर क्या रहेगा? ऑलवेज सेकेंडरी रहेगा. So therefore ये अल्कोहल का टाइप क्या हो गया? सेकेंडरी अल्कोहल. So isopropyl alcohol is an example of 2 degree alcohol, that is secondary alcohol. एंड सी, अगर कहाँ पे सी दिखता है सी और उसके साथ कोई भी फंक्शनल ग्रुप अटैच है, सो उस कार्बन का नेचर क्या रहेगा? टर्शियरी रहेगा. मतलब ये कौन सा अल्कोहल है? यस, इट इज अ टर्शियरी अल्कोहल. Okay, so as the nature of these three alcohols are not same, that's why conditions are not same. That's why conditions are different, because the condition depends on the nature or the type of alcohol. So as here type of alcohol is a primary, so for primary alcohol the condition is a maximum or strong or drastic conditions are here. High reaction occurs at high temperature with high almost 100% concentration of what? Sulfuric acid is needed. But when type of alcohol is secondary alcohol, then condition becomes somewhat mild. Now concentration of sulfuric acid needed for dehydration is a 60%, and temperature also drops to 100 degrees Celsius, that is 373 Kelvin. And when type of alcohol is a tertiary, conditions are very mild. We need just 20% concentrated sulfuric acid, and temperature is a 90 degree, that is 363 Kelvin. Okay, got it? So you have to remember the type of alcohol. If you know the type of alcohol and the condition, and depending on that, you have to use the conditions. for that particular dehydration reaction. Got it? Yes. So it's about dehydration of alcohol by using concentrated sulfuric acid. Now this dehydration by using what? By using हमने यहाँ पे क्या डिस्कस किया? कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड के साथ हमने डिहाइड्रेशन रिएक्शन डिस्कस की. अब ये जो डिहाइड्रेशन रिएक्शन है ना, इसको हम बोलते हैं, इट इज कॉल्ड लिक्विड फेज डिहाइड्रेशन, बिकॉज दिस रिएक्शन occurs in liquid state or liquid phase, so that's why this reaction is called liquid phase dehydration. So dehydration of alcohol by using concentrated sulfuric acid is called liquid phase dehydration. Okay, you'll find one more question on this particular reaction, that is this particular method of preparation of alkene, that is which among the following alcohol gets dehydrated easily. Okay, और ऑप्शंस क्या रहेंगे? ऑप्शंस क्या रहेंगे? डिफरेंट अल्कोहल्स रहेंगे और वहां पे एक अल्कोहल देखेगा आपको कि जो टर्शियरी होगा. ओके, तो टर्शियरी अल्कोहल है, वहां पे कंडीशन सबसे माइल्ड है, मतलब ये इसकी रिएक्टिविटी सबसे ज्यादा है एज कम्पेयर टू दिस. एज कम्पेयर टू दिस मतलब लीस्ट रिएक्टिव अल्कोहल टुवर्ड्स डिहाइड्रेशन बिकम्स व्हाट? Primary alcohol. Okay, it is this alcohol, isopropyl alcohol, it's an example of second alcohol. It is having intermediate reactivity, and this tertiary alcohol, it readily undergo dehydration. So dehydration की order क्या हुई? Yes, what is the order of dehydration of alcohol? 30, 20 and 10. Tertiary alcohols, they get dehydrated easily as compared to secondary, as compared to primary. Follow? Good. Now let's see dehydration by using, again same dehydration of alcohol, but by using another reagent. Okay, and the another reagent is alumina. Al2O3. Al2O3. Now with this dehydrating agent, some interesting conditions are here. Al2O3. Al2O3, and here also same. So Al2O3. So it's a dehydration which is by using what? Not concentrated sulfuric acid. So dehydration by using alumina, Al2O3, that is alumina. Now this dehydration is called, it is called vapor phase dehydration. It is called vapor phase dehydration. So the reactants and products are same, only conditions are different. Instead of concentrated sulfuric acid, now here we are using what? Alumina. Okay, which is also dehydrating agent. So again, if type of alcohol is a primary, then temperature needed is a 623 Kelvin. How much? 623 Kelvin. Interesting conditions are here. You can easily remember these conditions with alumina. If type of alcohol is secondary, then decrease this temperature by 100 degrees. So it becomes 523 Kelvin. 523 Kelvin. And when type of alcohol is tertiary, again decrease this temperature by 100 degree. So it becomes 423 Kelvin. Reactants and products are same. Again, order of dehydration is also same. But this dehydration is called vapor phase dehydration. Okay. So therefore, how we can explain this reaction? Yes, let us have this example. This example, ethanol. So when the vapors of this ethanol, they are passed over what? This heated alumina at this particular temperature, that is 623 Kelvin. They give us what? Ethene or ethylene. Okay, so it's the first method of preparation of what? Alkene, that is by dehydration of alcohol under this title, that is elimination reaction. Yes. Now let's see second elimination method of preparation of alkene, method number 2. Okay, first में second reaction है. ये जो रिएक्शन है ना, इसको हम बोलते हैं dehydrohalogenation reaction. कौन सी रिएक्शन है? dehydrohalogenation reaction. Dehydrohalogenation. Again here D stands for loss, removal, elimination. Hydrogen as well as halogen. Hydrogen as well as what? Halogen. So minus of HX. It's a dehydrohalogenation reactor. Okay. So HX कौन लॉस कर सकता है? अल्किल हलाइड लॉस कर सकते हैं. मतलब यहाँ पे हमारा रिएक्टेंट कौन सा रहेगा? अल्किल हलाइड. Now how alkyl halides are represented? Yes, they are represented as a RX, where R means what? It's the alkyl group. Maybe methyl group, that is CH3. Maybe ethyl group, that is CH3, CH2 dash. Okay, and so on. Maybe propyl group, that is propyl group. Similarly, this X, it may be Cl, it may be Br, it may be I. Any alkyl halide except fluoride, because fluorides are generally found to be explosive in nature. So Rx is going to be our reactant, And if you carry out this dehydrohalogenation of Rx, then that is going to give us what? Our desired compound, that is alkene. Okay. So let's have once again example CH3, CH3, then CH2, and then Cl, Cl. That is CH2 and H. That is CH3, CH3, CH2, and Cl. Now this reaction is carried out by using alcoholic solution of caustic potash. KOH is called caustic potash, and NaOH is called caustic soda. KOH and NaOH. Now here solvent plays very important role. In alcoholic medium only, this alkyl halide undergo dehydrohalogenation reaction, that is elimination reaction. But instead of this alcoholic KOH, if you use an aqueous KOH, then there occurs substitution reaction. Okay, and the product of substitution of alkyl halide is not alkene, it's alcohol. So we have to boil this reaction mixture or we have to heat this reaction mixture. So when alkyl halides are heated with or are boiled with what? Alcoholic solution of KOH, they loses molecule of what? HX, that is HCl in this case, HCl. Okay, giving alkene. So again, H plus this electron pair gets shifted between these two carbon and Cl departs by taking this electron pair. Okay, giving this alkene, that is CH2 double bond, CH2 double bond, CH2, and plus there is no loss of what? HCl. Actually, loss, it's a dehydrohalogenation reaction, but whatever this HCl or HX gets lost from alkyl halide, that is acid, and that gets neutralized by this base KOH. Means there occurs simple neutralization reaction. So HCl plus KOH, HCl from this alkyl halide plus KOH, it gives us what? KCl and H2. So the products, secondary products are KCl and a molecule of water. Now what is this? Yes, it's ethene or ethylene. Okay, so CH3, then CH2, and then Cl. Now again in this reaction, halogen and hydrogen. Okay, halogen and hydrogen, they get lost from which carbon? Adjacent carbon. So if I label this as the first carbon, this becomes carbon number 2. So it's a 1,2 elimination reaction. 1,2 elimination reaction. Okay, also called beta elimination reaction, because it is the functional group present on this carbon. So with respect to this carbon, it is the adjacent carbon. So it is the beta carbon, because it's alpha, it's a beta carbon. So hydrogen gets lost from which carbon? Beta carbon. That's what is called, also called beta elimination reaction. Okay, good. CH3, then CH, then Cl, or even Br also. You can also have another halogen atom. It's a Br, that is bromine, and then CH3. CH3 plus same. You can also use NaOH, but alcoholic. Okay, you can't use here aqueous medium. Again, same on boiling this reaction mixture. Now Br is present on this carbon. So with respect to this carbon, it is adjacent carbon. It is also adjacent carbon, and again they are equivalent carbon. Okay, like dehydration of alcohol. So you can remove H from any of this carbon. Okay, so if I remove H from this carbon, then here is a formation of double bond. So I will get this CH3, then CH, then double bond, CH2, and plus what? Loss of H and Br. But there is no loss of what? HBr. That HBr, which is a halogen acid, that gets neutralized by this base, which is a KOH, giving salt and water. So they undergo neutralization reaction. So the salt in this case is a KBr and a molecule of what? Water, H2. Okay. So what is this? It's a propene. Similarly, if I use here the CH3, then C, then CH3, then CH3, and then let's have iodine, halogen. Iodine as a halogen atom. Plus what same? It's a KOH, alcoholic solution of KOH, alcoholic solution of what? Same base, that is alkali, use alkali KOH on boiling this reaction mixture. Okay, with respect to this carbon, because this carbon carry halogen atoms, so with respect to this carbon, all these three carbon atoms are neighboring carbon atoms. So we can remove H from any of this carbon because they are equivalent carbon atoms. So let's remove H from this carbon. Okay, so that here is a formation of double bond. You'll get this CH3, then C, then CH3, then double bond CH2, and plus what? HI gets lost, that gets neutralized by this base, giving what? Ki, that is potassium iodide, and a molecule of what? Water. This compound is again same, it's isobutylene. Okay, So it's about second elimination reaction, that is a dehydrohalogenation. The first one is a dehydration. So dehydration of alcohol as well as dehydrohalogenation of alkyl halides results into what? Alkene. Got it? Yes. Now, under this title, dehydration of alcohol as well as dehydrohalogenation of alkyl halide, you find one rule, very important rule. It is known as Saytzeffs rule. Saytzeffs rule. Sometimes it is also called Saytzeffs rule. Saytzeffs rule also. Saytzeffs or Saytzeffs. Okay. So let us have one example. Let's consider dehydration of alcohol. Dehydration of alcohol. That is this particular alcohol. CH, then CH, CH2, then CH, then OH, and then CH3. Correct? Yes. Now this alcohol, yes, it is called secondary butyl alcohol. It's a secondary butyl or butyl, secondary butyl alcohol. And the type of alcohol is a secondary. Correct. Now, as the alcohol is secondary alcohol, means the condition becomes 60% concentrated sulfuric acid, and temperature is a 373 Kelvin. Okay. Now, it's an interesting example. Now, OH is present on this carbon, and with respect to this carbon, both these carbon atoms are adjacent carbon atoms. Okay, but they are not same. One is present as a CH2. You can't consider this because it's not second carbon, it's the next third carbon from this carbon. So these two are the second carbon atoms, and they are not equivalent because the substituents present on these two carbon, they are not same. Here this carbon carry 2H and this carbon carry 3H. Okay, means we can remove H from any of these carbon atom, either from this carbon or this carbon, resulting two different alkenes. Okay, means in this case we get two products or two possible products are here. The first one is obtained by removal of H from this carbon, so that here is a formation of double bond because dehydration involves loss of H and OH, so creating double bond between these two carbons, giving this alkene CH3, then CH2, then CH double bond, CH2. Okay, alkene is called but one in. It's a but one in, and the second one is obtained by removal of H from this carbon. So look at this CH3, then CH double bond, CH single bond, CH3. Now this alkene is called, it's a but 2-ene. It's a but 2-ene. Means but 1-ene and but 2-ene are the dehydration product of what? This secondary butyl alcohol, along with loss of what? H2 molecule, H and OH or H and OH. So plus water molecule, one water molecule gets lost. ये जो रिएक्शन है ना, यहाँ पे दो प्रोडक्ट्स पॉसिबल है, दो अल्कीन. सो ये रिएक्शन आप अनबैलेंस फॉर्म में भी लिख सकते हैं. ओके. Now according to this rule known as Saytzeffs rule or Saytzeffs rule or Saytzeffs rule, this alkene is obtained in a larger proportion, meaning this alkene is the major product, so that this becomes what? Minor product. So two products are possible, but1 and but2. Okay, now why this product is obtained as a major product? That is explained by Saytzeffs rule. What this rule says, whenever two or more alkenes are possible during dehydration of what? Alcohol, then the alkene with more number of alkyl group. Alkene with what? More number of alkyl group is always obtained as a major product. So this is the alkene where this ethyl group is present as an alkyl group. So this alkene contains how many alkyl group? Only one alkyl group. But this alkene, it contains this methyl and this methyl. So it contains how many alkyl group? Any alkyl group. It may be methyl, ethyl, propyl, decyl, whatever it may be. So this alkene, want to count just number of alkyl group, not nature of alkyl group. So this alkene contains how many alkyl groups? Two alkyl group, and this contains only one alkyl group. Okay, correct. So that's why this alkene is obtained as a major product. That is the Saytzeffs. Means during dehydration of alcohol, that alkene is obtained as a major product, which is more alkylated. It is known as what? Saytzeffs. Okay, so same rule, you'll find same rule, or you can apply same rule in this case also. In this case, now what is this? Yes, now class of compound changes to chloride. It's alkyl halide. Previous one was alcohol. Now this becomes secondary butyl chloride. Secondary butyl what? Chloride. That is alkyl halide. Okay, it's a dehydrohalogenation reaction. Dehydrohalogenation reaction. which is carried out by using alcoholic solution of what KOH, alcoholic KOH on heating this reaction mixture or on boiling this reaction mixture. Again, two products are possible. Same products will get same product, but 1 in and but 2 in. Okay, it's a dehydrohalogenation, means it involves loss of hydrogen and halogen, and halogen they departs from neighboring carbon atom. So Cl resides, which is halogen present on this carbon. So with respect to this carbon, both of these carbon atoms are adjacent carbon atoms. Correct. Okay, so we can remove H from any of these two carbon atom. So if I remove H from this carbon, then double bond gets formed between these two, and when I remove H from this carbon, double bond gets formed between these two carbon atom, giving same alkenes. Okay, hope got idea about this rule, important rule, which is a Saytzeffs rule. Yes. So we'll discuss that second reaction, that is elimination reaction, in my next vlog. So till then, bye and take care, and don't forget to subscribe my channel. If you like, then please comment and share with your friends. So have a good day.